I downloaded all those files and then I put it into the folder dictionary. Yeah, it you can put the files in your directory. Actually, some of them I already put into the preview section, like the dictionary example, inventory value. But let's discuss now because I think it is good to understand the concept of map or dictionary using this example. First, let's see the dictionary example. So in the dictionary example, as you know, we have the key and value. We have the key and value, key and value. So if I want to know the key, then you can just call from the dictionary, which is the ages, and then I would like to know the key. Okay. And then you can print all the key. So the basic idea is similar to list, okay, but you can call the key. If you want to know the value, then you need to put one method, which is dot values. In this case, you will see the value that is 25. Maybe I can show you. Oh, it seems I make it redundant. Okay, let's see this one. Okay, let's suppose I have the ages. We have the key and value, key and value, key and value. So I want to know only the key. So the key is the name, Alice, Bob, and Charlie. Then I can get the keys only, Alice, Bob, and Charlie. If I want to know the values, then you can just use the dot values, and everything of the value of the key, it will be printed. Now, if I have another kind of for loop, I want to check all the items. It means I want to see the key and value at the same time. So you can call the dictionary name and then you can use dot items. We can see the key and value at the same time. In this case, I can see Alice 25, Bob 30, and Charlie 35. Okay. Now, let's see how we can apply it to a kind of inventory problem. So I took this one from one reference in the book. So we can see, let's say I have this inventory. So apple, I have 10 items. For banana, I have 5 items. For the orange, I have 8 items. So I can make a function, as you know, for every kind of data structure or for every kind of algorithm, we need to have at least 2 operations, insert and remove. So in the inventory, we have also the same operation, insert or add and remove. So we have the item and I want to add the item. Let's say I want to add apple, so it is the item, and then the quantity, it means the quantity that I want to add into the inventory. So if the item is in the inventory, then let's put more item. If it is not in the inventory, then let's just make the item quantity equals to the quantity. So if I want to remove the items, then I can check if item in the inventory, and then please check first how many items in the inventory. If the item in the inventory is above the quantity, so it means if I want to, let's say, I have the item is 10, but I want to remove 20. Is it possible? It is more than the inventory quantity, so it is not possible. Then we need to make like this kind of if. Okay. So if it is higher than the quantity, it means if I have the inventory is 10 and then I want to get 3, okay, then you can just do minus. If it is not available, then as you know, we can give the message. This is not enough. Or if the item is not in the inventory, then you can mention the item is not in the inventory. I can get the quantity. So how many items in the inventory? Then if the item is in the inventory, just return the quantity of that item. If there is no item or if there is no quantity, then you can just return 0. Okay. So if you run this one, the first is add item. Okay, I know the apple. We start with the inventory. This one. We can add the item. Apple is 3, so it means I will add 3 items of apple, and then I will add 2 items of banana, and then I will show the updated, and then let's say I remove orange. So orange we have 8, so I want to remove 4 items, then I can get the current quantity. So let's see. This one is in the dictionary. Where is this one? This is in the stack. Sorry. Okay. Let me just copy this because the location of this untitled is in the different folder. So if I run this, then the initial inventory, you can see that the apple has 10, and then the banana has 5, and then the orange has 8. And then whenever I add the items, so the inventory will be added. And then I remove orange 4, so the current quantity of apples become 13 and the current quantity of orange become 4. Okay. You can have the idea about the inventory using this simple code. Of course, when you do with your team project, you may have more complex problem than this one. So if you have complex problem, let's say the apple, so you can put another kind of information. For example, the expiry date. If you can, so you can put more items. Maybe you can have the list. Okay. So the first item in the list is the number of inventory, and then you can say like the priority queue. So this item will be the priority. or the other item can be the later priority. Okay. So another example, I guess you already know. Oh, maybe I will put this one later. So last time we already learned this. If you still remember, we learned about the recursive. So this recursion, it used the dictionary. So the dictionary, here we want to know what is the node that we visit, and then what is the cost of that location, and then how many quantity that we want to deliver. So if the node is not in the cost dictionary, this one is the cost dictionary, means I know that from factory, this is the key. I can go to warehouse, I can go to the retail house, so the distance or the cost is 10, the cost is 20. So I can just make a kind of table from the factory. I can go to the warehouse, I can go to the retail, and then the cost is 10 and the cost is 20. If I have the warehouse, and if I want to go to the retail, then the cost is 5. So you can represent in the dictionary like this one. The quantity, it means, yeah, how many items that you can bring. Maybe you want to deliver the product with truck, then yeah, there's a specified number of items that you can bring. Let's say from the factory to warehouse, okay, you can have the same from the factory to warehouse. So it shows that I can deliver 100. From the factory to retail, I can see that I can deliver 200. So for the warehouse to retail, I can deliver 150. So you can represent with this kind of dictionary. And if you want to calculate the total cost, yeah, you can consider this kind of dictionary. And then let's see, if the node is not in the cost, then return 0. Means, yeah, I want to know the cost from the factory, and then I want to know what is the total cost if I want to visit from the factory to warehouse, factory to retail store, and then I have the warehouse to retail store. Then I will do the total cost starting with 0, and then for every of the node in the dictionary, I try to visit it and then check, and then I will calculate the total cost. So if you still remember, it is the recursion. Okay. Calculate total cost is the function name, and then we are going to check the child node. Means if I now start with the factory, so I will check, is there any child node? Okay, I have the warehouse, so I will check what is the cost for going to the warehouse. And then is there any child node? Okay, I know there is a retail store, so I can calculate the total score. And I also can multiply with the quantity. So this is the formula. In order to understand the details of this one, so let me give you another kind of example. Maybe some of you have not known about Python before. So let me give you a little example about two-dimensional list. So this two-dimensional list means I have a list and then I have another list inside the list. So usually we use this one as a matrix. We can represent this kind of list, or you can represent this as the dictionary that we saw before. So for example, I have this matrix. This matrix is 1, 2, 3. This is the first row, and then 4, 5, 6. This is the second row, and then 7, 8, 9. So this matrix is 3 multiplied by 3. We have 3 rows and we have 3 columns. And then I can look for each row. As you know, this kind of problem, you can see it as the list. You can see something like this. So the first item in the list is a list. The second item in the list is a list. And the third item of the list is a list. So let's see if I close this one first. So for any row in matrix 1 and print row, what is the result? Oh. Let me close this. So for the first row, I will print a list. The second row, I also print another list. The third row, I will print another list. In this case, I can consider that in the list, I have another list. So I can make the column in the row, because row is a list. So we can have the print, and then I want to print the column. So let's say I want to print it in the same line. Okay, so we have the n. It means I want to end with the space. If I end with the space, then it will be in the same line. After I finish with this one, I want to go to the next line. So I just use the print. It will go to the next line. So you can see, if I print the row, then it will be a list. If I print the column, then it will be the value of every element in the list. And then I will give the space, so the element will be printed in the same line. The second row, we have a list, and then we can print every of the element. The third one is a list, and then we can print it in every element. So in the idea of this two-dimensional matrix, we can have two elements. So if it is 0 and 0, then it is the element of index 0, which is this one, and then 0 is the element of the index 0. Then I will print this is 1. If I print matrix 1, 2, then it is the index of matrix in index 1, and then I want to print the index 2 of the index 1. Then the index 2 is this one. Then I will print 1 and 6. Okay. With this idea, I would like to revisit the this one, yeah. So if you still remember this one, we learned about this one in the recursion. So in the recursion, we have this item in the inventory. So we have 10 items, we have 20 items, and let's say these items are in the big box. Okay. So I have a very big box like this, and then there is a box here, and it consists of 5 items. There is another box. I can see this, it consists of 15 items. And there is another box, and it consists of 2 other boxes. So let's say this one is 3, and we have 7. And then there is another box that is 10. Okay. Then I want to know how many items inside this box. So in this case, it means you want to know as a kind of multi-dimensionalist. So if it is a multi-dimensionalist, you can use the two-dimensionalist that I explained to you, or yeah, we can use the recursion. Okay. Yeah, please look at this one. I hope that it will be helpful for you to design your team project. Okay. So let's continue with the hash table. So we finish. On Monday, we already finished with the first part. Now let's learn about the collision. What is the meaning by collision? Do you know collision? It's like this, sabu. So collisions occur when different elements are mapped to the same cell. So you can see from this SSN. So we call it SSN. This is the social security number. This social security number and this social security number is different. But as we know in the previous example, we want to consider only the last 4 digits. We want to consider only the last 4 digits. If we look at the last 4 digits, so we know that it is located in the same place. Then we call this is collision. So in the collision, we need to handle how to put the elements. If they are in the same location, then we need to create a kind of list, or we need to create another kind of place to store the items. Yeah, we will learn more how to place this item. So in this case, we have a hash table of size 13. What is the meaning size 13? This one, we have 13. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then I have 10 items. I have 10 items, so this is the item 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we are going to separate them with the separate chain. So we call this is the separate chain. We have another chain. Okay, so we call this is chain, but the chain is separated. We have another chain. In this case, we can consider a kind of compression function. Do you still remember compression function? So last time we learned about the compression function. Here. The compression function means I want to change from any integers into a kind of location in the list or in the array. So I have the integer value 54. So I want to know where should I put this 54? Because I have 13 location, I have the size 13, and every integer I can just consider it with the function k mod 13. Because every integer I want to put only in the 13 space. So let's say if I have the value 54, 54 mod 30, what is it? It is 2. Because it is 2, then I put the item 54 in the index 2. Now let's say I have the item 28. 28 mod 30. What is the result? It is also 2. So I put this item in the index 2. Because they are collide, or we call this collision, so we can make a separate chain. So for the simplicity, we do not show the values associated with the keys. So we just show the keys. Okay. So we call this is separate chain. Let itself in the table point to a linked list of entries that map here. Please still remember linked list. So we can store the items. If 54 is first, then it will be the head. And then we can go to the next. And then we can go to the next. So we can say this is a linked list. And this is the head. And this is the tail. So separate chaining is simple, but requires additional memory outside the table. So it's simple. You can just make another chain like this one. You can make another chain like this, but we need to have more memory here. It means if we have this size 13, we have another memory in this case, n divided by how many items that you will have. Okay, so later we will consider this like the n divided by the size divided by 2. So this is the very basic separate chaining with the map. As you know, for every operation of the algorithm, we have insert and we have remove. For the insertion here, if we want to get, if we want to get only, then I would like to get according to the HK. HK means the compression function. In the compression function, we can directly know what is the index. So I want to know the index in the, let's say this is array A, and then I want to get the key, or I want to get the value. If I want to put, so I will put the key, and then I want to put the value V, and let's see T. T is the place where we want to put this item. If T is null, then N will be N plus 1. So return T. So in this case, let's A be the new key. If it is not a new key, then you need to have another linked list. So if you want to remove it, then you can just call the HK and then you can remove. So this is the very simple map or dictionary. If T is not null, then it means we found the key, and then N will be minus by 1. So we call this is the hash map for the chain, or the hash table with the separate chaining. We can get the item in the bucket, we can set the item in the bucket, or we can delete the item in the bucket. And then we can do the iteration for every element in the bucket. So the bucket means the separate chaining that we have. If you want to set the item in the bucket, this is the way. And if you want to delete the item in the bucket, so this is the method. There is another way to deal with the collision. The first part is the separate chaining. So the first is separate chaining. So we just put every element and then we create another linked list. But the second is linear probing. Linear probing, so the open addressing is the colliding item is placed in the different cell of the table. So linear probing handles collision by placing the colliding item in the next or circularly available table cell. Each table cell inspected is referred to as a probe. So let's say if I have a number, then it is a probe. Colliding items lump together, causing future collision to cause a longer sequence of probes. So let's see, like this. I have the keys 18, 41, 22, 44, 59, 32, 31, and 73. And it will be in the order. So let's start with 18. 18, I have this size is 13. Okay. Then I can make the compression function x mod 30. 18 mod 13. What is the result? It is 5. Okay. Then I can put 18 in the 5. Next, I go to 41. 41 mod 13. What is the result? It is 2. Then I can put 41 in the index 2. I go to the next 22. 22 mod 13. The result is 9. Then I put 22 in 9. What is 44? 44 mod 13, it is 5. Okay. Oh, in 5, we already have 80. So how can we handle this collision? We call this is linear probing because we need to put the element in the next empty. So we call this is in the next circularly available stable cell. So we go to the next. What is the next? It is in the 6. So 6 is empty. Then we put 44 here. Now let's see 59. 59 mode 13. What is 59 mode 13? Yeah. 6, 7, 8, 13 multiplied by 5. Oh, okay, multiplied by 4. What is 13 multiplied by 4? 52. Okay, then 59 minus 52 is 7. In the 7, okay, we just put 59. Now we have 32. 32 mode 13. The result is 6. Then how can we put in the 6? The 6 is already, we have an item in the 6. Then we go to the next. Oh, we have another item in the 7. So we go to the next. Okay, number 8 is empty. Then we put here as 32. Now we have 31. 31 mode 13. The result is 5. Let's see. 5. Okay, we have the item. 6. We have the item. 7. We have the item. 8. We have the item. 9. We have the item. 10. Okay, is empty. So we put 31 in this empty cell. The last one is 73. 73 mode 13. What is 73 mode 13? Multiplied by 6, 78. Yeah, so multiply by 5. If multiplied by 5, then 65. Then we have 8. We have 8, then oh, there's an item in 8. So we go to the next. 9. We have an item in the 9. Let's go to 10. We have an item in 10. 11. Okay, this is empty. So we put 73 here. Okay. So the final result will be like this one. Okay. So we call this is the linear probing. So with the linear probing, yeah, we can save or we can put the items. But what if we want to search? So after we put the keys and I want to get the values, that means I need to search. Then we need to define the method get. So how can we get the value? In this case, we can have the hash table A, and then if the A use linear probing, then we will get the K. We start at the cell HK. So HK, we know this is the compression function. In this case, the HK is the K mode 13 in the previous example. Okay. And then let's start with the P equals to 0. So we probe consecutive locations until one of the following occurs. So we call probe. It means we go to the index 0, and then we go to index 1, we go to index 2, we go to the index 3. Okay. So if an item with key k is found, finish. Or if it is an empty cell, finish. Or n cell have been unsuccessfully probed. Okay, so these three conditions, if it is already satisfied, then we finish the search. So the first is, we will repeat for every AI. If it is empty, then null. But if the get key is k, then let's get the value. But if it is not, let's try to go to the next. So we have the I plus 1 mod n, and it will be the next I. And then we will check p will be added by 1. So it will be repeated until p equals to n. So if every element has been checked and then we cannot find those elements, then return null. How if I want to update? Update means I want to change the value. So to handle insertion and deletion, we introduce a special object, we call it available. So it can be replaced with the deleted elements. In the specific function remove, we can search for an entry with key k. If an entry k, 0 is found, then we replace it with the special item available, and we return the element O. Else we return 0. So we search first. If there is an entry k, then after we remove it, we put available. So let's see this one. I want to find the key 5, for example. And after I found the 5, I will remove it and I will make this as available. So I put the notation available. So this available, it means I already remove this location, so it can be used for another item. If we want to put k, O is the values. So we throw an exception if the table is full. Okay, we know that whenever we have a kind of array, if every element already filled, then it is full. Okay. If there is no empty space, then the table is full. So if the table is full, you can have more strategy like you already learned before in the array. We have two kind of strategy. Do you still remember? First is the incremental strategy, and the other is the doubling strategy. Okay, if you want to increase the array, then you can use that kind of strategy. But let's say I just want to make an exception if the table is full. We start at the cell HK and then we probe the consecutive cells until one of the following occurs. If the cell I is found, then either empty or stores the available, or n cells have been unsuccessfully probed. So if you have like this, when we are putting the value, so let's say this one is already filled. O. Okay. And if this one is already filled, if a cell is found that is either empty or stores available, then yeah, you can put in this element. But if it is already filled in, yeah, you need to check consecutively until this cell is found, until we have empty. If it is not empty or if it is not available, then yeah, n cells have been unsuccessfully probed. So we will have another exception. So the exception is the table is full. So this is the code, how we can look at the probe has map. So we need to check whether it is available, and then how we can find the slot. And then yeah, how can we get the item, how can we set the item, and how can we delete the item. Okay, let's have a break. I will continue this one after the break.